Hello guys, welcome to our YouTube channel where we create a path of knowledge by bringing lectures closer to you. Please don't forget to like and subscribe on our YouTube channel for more of our videos. I'm Mai Banura. I'll be taking you through fluid power systems. Let's start with classification of hydraulic pumps. First, we have non-positive displacement pumps, and second, we have the positive displacement pumps. Let's look at non-positive displacement pumps. In these pumps, the fluid is pressurized by the rotation of the propeller, and fluid pressure is proportional to the rotor speed. So, since the fluid pressure is proportional to the rotor speed, this will cause a non-constant flow. So the flow will not be constant because there is variation with pressure. Pressure at a time will increase and pressure at a time will decrease, so thus resulting into a non-constant flow. So the flow here is not constant. Basically, these pumps are used for low pressures and high volume flow applications. So these pumps cannot withstand higher pressure applications. That's why such pumps are not capable to work against high pressures. So this is the reason as to why they are not designed for application in hydraulic systems. As we said, they work with low pressures. So they are designed to work maximum pressure of about 18 to 20 bars only. They are considerably used in chemical and oil industries where liquids are required to be transported from one location to another. Actually, examples here we have the centrifugal pumps and the propeller pumps. Something to note here, the output flow decreases with increase in system pressure. Output flow decreases with increase in system pressure. So some of the advantages of these pumps: the low initial cost because of less moving parts. There is low maintenance cost still because of less moving parts, because there are few parts of the pump to maintain. Simplicity in operation, I think that's clear. Then wide range of fluids are used. And then disadvantages: there is less volumetric efficiency, not suitable for higher pressure applications, and also such pumps are not self-priming, so they will require a positive sanction for smooth operation. So let's go to positive displacement pumps. In positive displacement pumps, output fluid flow is constant. This is the difference between the positive and the non-positive displacement pumps. In positive, the output fluid flow is constant, and in non-positive, the output fluid flow is not constant. Something else to note here, in these pumps, the output fluid flow doesn't depend on system pressure. These pumps deliver constant fluid flow in a cycle. The fluid flow is proportional to their displacement and rotor speed. Since output fluid flow is constant, the discharge quantity of fluid per revolution is constant throughout the system. These pumps are basically designed for higher pressure applications, unlike the non-positive displacement pumps that are capable of working with low pressures. These ones can work with high pressures. So the important advantage associated with these pumps is that the high pressure and low pressure areas are separated, and hence the fluid cannot leak back due to higher pressure at the outlets. Positive displacement pumps do not produce pressure, but they only produce fluid flow. So the pressure will be produced due to resistance in output fluid flow. Some of the examples of positive displacement pumps are the gear pumps, we have piston pumps, vane pumps, among others. Advantages here include capability to generate high pressures. There is high volumetric efficiency, and higher power to weight ratio. Let's also look at gear pumps. A gear pump comprises of two meshed gears revolving about their respective axes. These gears are the only moving parts in the pump. And gear pumps are positive displacement pumps. Therefore, they are suitable for a wide range of fluids and offer self-priming performance. Based upon the design, gear pumps are classified as external gear pumps, that's one. Second, internal gear pumps, lobe pumps, and Ureter pumps. So let's start with an external gear pump. An external gear pump consists of externally meshed two identical gears housed in a pump case. One of the gears is coupled with a prime mover. It could be an IC engine, it could be a motor, among others. So the one that is coupled with a prime mover is the driver gear, and the other that is driven by the driver gear is called the driven gear. In an external gear pump, the two gears come into and out of mesh to produce the flow. As the gears come out of mesh, they create an expanding volume at the inlet side of the pump, leading to pressure drop below atmospheric value. The liquid is then forced to enter the pump by atmospheric pressure. The liquid travels around the interior of the casing in the pockets between the teeth and the casing. Finally, meshing of the gears forces the liquid through the outlet port under pressure. Some of the advantages of external gear pumps is that they are quiet running. Since both gears are held by shafts, so they are quiet running, there is no noise, and they are routinely used for high pressure applications such as hydraulic applications. The disadvantage of these pumps is that no solids are allowed. Since these gears come into mesh with each other, so if solids are used, you'll find that the solid will be damaged, right? So fluids are the only ones used in these pumps. The common external gear pump applications include, we have various fuel oils and lube oils. There are chemical additive and polymer metering. We have industrial and mobile hydraulic applications such as log splitters, lifts, among others. Let's look at internal gear pumps. An internal gear has one internal gear inside a second outer gear. The inner gear has a shaft driven by a motor and has teeth that protrude outward. The outer gear has teeth that protrude inward, so the gear is internally meshed. So we shall be calling the large exterior gear as the rotor and the small interior gear as the idler. The arrows in this image indicate the direction of the pump and the liquid. Something unique about these pumps, they have a stationary crescent-shaped seal that separates the intake and discharge portion of the fluid. So let's look at how internal gear pumps operate. As the inner gear rotates, it meshes with and moves the outer gear. So liquid enters the suction port between the rotor and the idler teeth. So liquid is trapped in the gear spaces and is carried from the inlet to the outlet port. The stationary crescent-shaped seal is the one that separates the intake and discharge portion of the fluid. So the seal forces the liquid out of the discharge port. Internal gear pump applications include resins and polymers. We have alcohols and solvents. We have paint, inks and pigments, and all varieties of fuel oil and lube oil. Let's look at lobe pumps. A lobe pump has a working principle that is similar to that of an external gear pump. It consists of two rotors, which are called lobes, instead of the gears. One is the driver and the other is the driven. The lobes do not make any contact like the other ones in the external gear pump. The lobe contact here is prevented by an external gear, an external timing gear. So when the driver lobe is rotated by means of a prime mover, the driven lobe will also rotate. This creates an expanding volume on the inlet side of the pump. So liquid flows into the cavity and is trapped in the pockets between the lobes and the casing. Then the meshing of the lobes forces liquid through the outlet port under pressure. So I think, guys, you can see that the lobe pumps almost operate in a similar way as the external gear pumps, just that this one has the lobes and the lobes do not make any contact. Yet the other ones in an external gear pump, they mesh into and out of, they come into and out of mesh with each other. Some of the advantages of lobe pumps is the high efficiency, they are reliable, and they are corrosion resistant. So these pumps are commonly used in food applications because they handle solids without damaging them. They're also used in industries such as pulp and paper, chemical, beverage, pharmaceutical, among others. Finally, let's look at the Ureter pumps. A Ureter pump consists of two rotors, the inner and the outer. The inner rotor has one teeth less than that of the outer rotor, and the inner rotor is located off-center of the pump. So during rotation, the volume of each partition increases continuously, and then it increases with fluid, but then the volume decreases. So an increase in volume creates vacuum. This vacuum creates suction. Therefore, fluid enters the pump. As the volume decreases, compression occurs. The rotor and idler teeth mesh completely to form a seal equidistant from discharge and suction ports. And this seal forces the liquid out of the discharge port. So that's how a Ureter pump works. So applications here, we have light fuel oils, cooking oils, lube oils, among others. So guys, that's all with the gear pumps, and I think right now we can describe the various gear pumps, the 4 of them, and we can differentiate them in operation. But with operation, almost all gear pumps have the same principle, just that you just have to grasp the components of each gear pump, how it operates. When you get that, then everything will be simple. Thank you for watching. Please don't forget to like, comment and subscribe on our YouTube channel for more of our videos.